Hello, ladies and gentlemen. Mr. Dorfler here for another daily dose of Dorfler. This is part 2 of section 2 of chapter 16. In the first section, we talked about light and how weird it is and how it doesn't behave how we want it to. It kind of goes against everything we know of the natural world, but that is the natural world. So we got to study more of it. So if you want to, come take my honors chem class. So we can dive deeper into it. We're also going to continue talking about some quantum mechanic notions, but we're going to be focusing on what's called the electromagnetic spectrum today. Now, this video is going to be shorter than yesterday's video, and there's also going to be a homework assignment that is going to be made into a separate post just so you can find it easier, okay? So let's talk about the electromagnetic spectrum, shall we? It consists of light waves of all possible energies, frequencies, and wavelengths. So it's everything. If you see down here, it involves everything. And we're going to talk about the major players of the electromagnetic spectrum today. Now, again, I'm kind of promoting my honors chem course here. Excuse me, hiccup. But I also have a really incredible song that I play for my class. Called the Electromagnetic Spectrum Song, and it is a showstopper. It is a fan favorite. People ask me all the time to play it, and hopefully I can play it for you someday. Anyway, it's a broad range of waves. They range from radio waves all the way to gamma rays, the kind of rays that made the Incredible Hulk. But they all have very similar characteristics. Or at least some similar characteristics. They do differ in their wavelengths and frequencies. Radio waves, these are what are going to transmit signals from radio and TV stations. You have radar guns, cancer treatments. You can use radiation therapy. So all sorts of different types of waves that are on this spectrum are used in a variety of uses. And we're going to talk about those uses. Let's talk about radio waves. Okay, these are the longest wavelengths in the electromagnetic spectrum. Wavelengths range from tenths of meters to thousands of meters. So remember what a wavelength is. It's the distance between two neighboring identical spots. So tenths of a meter, that big, to thousands of meters. You're talking about, miles between two identical points. TV signals, AM, FM radio, if you still listen to local radio. Radar, okay, locating various objects. What is radar? Well, radar is defined as a system that uses reflected radio waves to determine the velocity and location of objects. These waves are emitted into the air and bounce off objects located within the air. These waves that bounce off objects and return to the location in which they were emitted. And many planes use transponders to enhance the signal received from the ground radar tower and to send enhanced signals back to the ground radar. One thing that you might also hear radar is when we have storms coming. Okay, that's what it sends. It sends radio waves out, and whatever particles such as rain, snow, sleet, debris, they're going to reflect back to the the radar station, and we call Doppler, and we can detect where storm fronts are. Microwaves. This is how basically I cooked everything in college, almost up until I got married. Microwaves contain electromagnetic waves with wavelengths in the range of centimeters. So we're getting smaller and smaller in terms of wavelengths, but we're also therefore increasing our frequencies. Microwaves are used to carry telecommunication signals over a long distance. Spacecrafts, long distance telecommunications, they got to talk. They use microwaves to transmit signals back to Earth. Properties of microwaves, they are reflected by metals. Okay, so that's one of the main things main reasons why you don't want to put any metal in a microwave, because it'll reflect it, and that's not good. Okay, but we can transmit microwaves through air, glass, paper, plastic, all your common materials. And here is how a microwave can cook food. When food is heated by a microwave, the microwaves produced by the microwave are absorbed by the food. Okay, so it's, it doesn't only go so deep, okay, about 3 to 5 centimeters. As the microwaves that are being produced are absorbed by the food, it starts to vibrate and rotate the water and other molecules that are contained in the food. And these vibrations are going to cause the molecules, they're going to cause the energy in those molecules to increase. And so as the energy increases within the molecules in the food begins to warm. But it's also why if you overcook food in the microwave, it tends to be dry because you're increasing the energy in the water molecules. Therefore, you're increasing the temperature in the water molecules, which leads to evaporation of the water molecules. So that's why food tends to be a little drier if you do too much time in the microwave. Infrared waves. These consist of electromagnetic waves that have wavelengths slightly longer than wavelengths of red visible light. So a lot of times you'll see infrared waves or infrared being used in like remote controls, like for your television. Okay. Heat lamps can also use this to warm food. Infrared light from the sun is going to warm the earth. A computer mouse, kind of like what I'm using here. I don't know if you can see. Come on. This mouse doesn't want to do it. But right here, we use a little infrared wave that is then detected and transmitted to help us navigate or, just move my mouse around like this. Infrared sensors on weather satellites can record temperature changes in the atmosphere and track movements of clouds. So again, all sorts of uses. We're really harnessing waves for our daily lives. Okay, it's what makes our lives easier, if you will. Ultraviolet waves. Ultraviolet waves are invisible than violet light on the electromagnetic spectrum. It has a higher energy, therefore shorter wavelengths than visible light. We do have UV light emitted by the sun. About 9% of the sun's energy is in the form of UV light. However, most UV light is absorbed by the Earth's ozone. That's why the ozone is very important, but you don't hear about the hole in the ozone anymore. So I'm curious to know if it's fixed. Some UV light can make it through the ozone and clouds in the atmosphere. And this is the light that causes us to get sunburns or tans, okay? Because we do have that a little bit. And that's good that we only get a little bit because you see, if you're out there too long without the proper care, you get really burned. And that's just a fraction of the UV light that's being produced. The majority of it is being absorbed and not allowed to pass through to the surface of the earth. So that's why it's very important. And the last things we're going to talk about are X-rays and gamma rays. Okay, X-rays, they have higher energy and shorter wavelengths than UV waves do. The wavelengths are about 10 to the negative eighth meters. X-ray image, which you may or may not have had in your lifetime. I know I've had a couple. These are made by passing X-rays through the body. Most of them will pass through the body. And these waves that pass through the body are going to be absorbed by a photographic plate, which produces an image. X-rays are also or can also be absorbed by bones and other tissues. And so those waves don't make it through your body. And so we get this image, much like what we see here on the bottom. So this bone here absorbed it, and we now have this nice little image here. And lastly, we are going to need to talk about, I don't like when it does this, gamma rays, okay? We cannot follow the footsteps of the Hulk because obviously that is a somewhat fictional character, as far as we know. But these have the highest energy, and it's got a wavelength as small as 10 to the negative 10th meter, so that's incredibly small. But we can use gamma rays to help treat and kill cancer cells and other disease cells. However, dangers of X-rays and gamma rays, they have high energy that could kill living cells within the body. And they could even turn living cells, because of their high energy, into possible cancerous cells. So there's a give and take when you get to this end of the electromagnetic spectrum. So anyway, for the majority of it, it helps us a great deal in our daily lives. So that is going to complete section 2. I told you it's going to be short. Again, the homework assignment for section 2 is going to be in a follow-up post right after this video. And also want to say that you will be getting our next day, which should be like December 7th, Monday, you'll be getting the or sometime soon, you'll be getting the I can't say it, the quiz review for sections 1 and 2. There we go. So you'll get that. You'll want to complete that because your quiz will be coming up either Tuesday or Wednesday of next week. So make sure that you are staying on top of everything. Okay, getting towards the end of the semester, and there are a few individuals who need to get caught back up real quick. Okay. Anyway, have a good day, everybody. I'm going to call it a day on this video. Have a good one.